Have you ever placed a redstone torch, connected some dust, flipped a lever, and then just stood there thinking, wait, why did that actually work? That moment of confusion, that is day one of every electronics classes, and today we fix it in this real world. With Redstone, welcome to the DigitalNomix. I am Mitesh Khainar Patil, and this is episode 1 of Electronics. By the end of this video, my every wire, uh, every lamp, every switch you see in real electronics, it will look exactly like a redstone build because it basically is one. Let's go. Okay, so first concept is voltage. What is mean by voltage? Let's understand about this using redstone components. So I am using a redstone torch. Uh, Place a redstone torch. See that signal. See that signal strength. 15 blocks of power radiating out. You actually know, but this is not 15 blocks. It is around 8 blocks of redstone dust. That pressure, that push it gives, that is a voltage in real electronics. A voltage is nothing but a pushing of electricity for forward through a circuit towards the output terminal. I am repeating again. This is our redstone line and this is my output. That is a redstone lamp, and I am going to place a redstone torch. See this signal strength. Uh, Here voltage uh, is nothing but here redstone is nothing but a force that pushes electricity forward through a circuit, meaning that this is our redstone and this is pushing our electricity forward through a circuit towards the output terminal. Now head to our current. Current is the actual flow. Think of it as how many redstone particles are moving through your dust right now. Voltage says go. Current is actually goes. Two different things. Same circuit. Here is an easy way to lock this in. Uh, Voltage is the water pressure in a pipe. Current is the actual water flowing. The pressure makes it move, and the flow is what moves. Now comment below, pressure or flow. Which one is voltage? Let's see who got it. Now this is where it gets real. Look at this long line of redstone dust. Watch what happens to the signal as it travels. Did you see? Signal is dying at midline. That right there is resistance. In electronics, resistance is anything that fights against current that trying to flow. The longer the wire, the more is the resistance. The thinner is the wire, more is the resistance. Your redstone dust just shows you resistance in action. That is, if you are giving an electric supply, this current is flowing through the circuit, but its power is losing because of a a force that nothing but a resistance, and resistance is nothing but a force that actually fights or conflicts with a current that flow through the circuit. Every time you add a repeater to boost your signal back to full power, you were fighting the resistance. That's literally what engineers do with uh, circuits every single day. You were already solving real electrical problems. That is, if I don't use this redstone repeater, then electric power will get lost. But if I add redstone repeater, then this power will be quit higher and fights back resistance. So this redstone repeater is actually a diode in real life. Diode is nothing but a component that pushes electricity in only one direction. Now drop a redstone torch in the chat if your signal has ever died on a long line and you had no idea why. You know now a resistance. That's it. Now let's move to next component, that is a LED. Next is LED. LED stands for light emitting diode. It sounds very complex, but look at this redstone lamp. If I turn power on, then light glows. If I turn power off, light off. That is, it goes dark when power is not applied. That is an LED. Give it current, it produces light. Cut the current, lights out. Exact same behavior. But here is the part most beginners miss. An LED is sensitive. Too much current and it burns out. Just like how your lamp doesn't care about signal strength and differences much. But a real LED does. So in real electronics, you always protect an LED with a resistor. Beside it, the resistor is the LED's bodyguard. We will go deeper into resistors in episode 2. For now, just remember that a LED plus resistor always together will work. Now last one for today is a switch. In real electronics, a switch opens or closes a circuit. Open is equivalent to no current flows. Closed is equivalent to current flows. In Minecraft, that is your liver. Lever down, circuit is open, and lever up, a circuit is closed. You see, you use this every build. You use these components in every build that you already built during playing Minecraft, and your button block. That's a momentary switch in electronics. And your button block, that's a momentary switch in electronics. It closes the circuit for one brief pulse for a short moment, then opens again automatically. Lever stays on, button pulses on. Two different switch types, both exist in real life. As you see that if I give input, if I turn on, then light will be glow for a moment. Quick one. Which would you use to control your bedroom light in real life? Lever or button? Think Minecraft logic. Answer in the comments. Alright, rapid fire recap. Voltage is voltage is voltage is signal strength. The push, the current is what actually flows. Resistance is what that fights the flow. LED is your redstone lamp. Switch is your lever. You just learn 5 core electronics concepts in Minecraft. Episode 2, we will go deeper into resistors, capacitors, power sources, and we will build a working logic gate in Redstone and show you exactly how it matches a real circuit board diagram. If that sounds wild, it is. Subscribe. I will so see you in the next block.